So, hello to you all. Before we get started, we briefly introduce ourselves. Johannes, would you like to start?
Thank you, Tero. So my name is Johannes Karjalainen and I work as an additive manufacturing specialist in Etteplan. I have been now working in Etteplan for 3.5 years, almost 4 years, and in total I have 7 years background in additive manufacturing.
My name is Tero Hämeno and I'm the department manager of additive manufacturing at Etteplan. I have been in engineering business over 16 years now and the latest years heavily involved in additive manufacturing. Before we start today's topic, briefly about our company. So Etteplan is an engineering service company, over 3,500 engineers and 3 service areas. We provide solutions for industrial equipment and plant engineering, software and embedded solutions, and technical documentation solutions to world's leading companies in the manufacturing industry. But in the field of additive manufacturing, we are one of the forerunners at Nordics. Over the past years, we have gathered a lot of knowledge from this new technology, and our AM services are already quite extensive. We are offering AM engineerings, trainings, purchasing support, and factory consultancy for additive manufacturing. I'm pleased to host this set of 4 webinars with my additive manufacturing experts. We started from how to find suitable AM applications. Then last week, we focused on AM design. The last 2 ones are linked to a cost and industrialized AM production. These topics were meant to speak at the rescheduled 3D and new materials fairs at March and at Tampere, but we are pleased to be able to share our message via these webinars. Johannes, your turn. Thank you.
Okay, thank you, Tero. So on the right-hand side, you can see go to webinar screen. You can use that for questions. I'm not going to answer them during the presentation. We will hold up those for the last 5 minutes or so. So this is going to be 30 minutes webinar, and for the last minutes, we will open up the webinar for questions, and hopefully I can answer those. Last week, colleague of mine, Erin Komi, gave you an excellent presentation about simulation-driven AM design. It's now available in YouTube if you missed the previous coffee session. She had this one slide, which I want to highlight before getting into the topic of the day. Added value comes from design. This is the most important lesson in additive manufacturing, and it shouldn't be ever forgotten. Remember to utilize new degrees of freedom provided by AM and try to utilize those to design better products with added features and benefits for the customer and end user. That is basically the key for success in additive manufacturing. And I believe that everyone working with AM can agree on that matter. After said that, that doesn't apply to all people working in manufacturing industry overall. There are plenty of people who are working in different organizations and different departments who might not be such a big fanboys of 3D printing, and I cannot blame them. They are human. And most of the organizations are not really encouraging people to take a risk and make a change. Let's take an example of that. So for instance, guy working in purchasing department might need to get a spare part as soon as possible. He knows that additive manufacturing can have short lead time, but he has no clue about the cost of AM part. So basically, he has 2 options. One, use traditional supply chain, which maybe has 3 months lead time or something like that, and cost is 1,000 euros. Okay. Option number 2, start searching for new suppliers who provide 3D printing services, sign NDAs with them, send RFQs, wait for answers, and in the end, you might find out that cost is just ridiculous and you have lost 4 weeks calendar time and you still need to place order for traditional supply chain. At the same time, his boss probably knows that 3 months is the best possible lead time at the moment with current supply chain. So it just makes sense to play it safe and place immediately order from basic supply chain. It's too big risk to start building supplier network without knowing the result. Waste of time. Let's take another example from management. Let's use R&D manager as an example, who, for example, needs to deliver small facelift for one product family within the given budget. It could be interesting option to utilize 3D printing and create some extra value for customer, but well, there is a risk that production costs will be too high and targets won't be met. It doesn't pay off for R&D manager to take this kind of risk. He will get the same reward no matter if he does small incremental improvement or bigger innovation. It's enough if he can deliver something fulfilling requirements within the given schedule and budget. And there is a significant downside if he decides to start 3D printing project. If it fails, that will cause extra costs, delayed schedule when part needs to be redesigned for traditional manufacturing, and probably some angry emails, phone calls from customers or from upper management. So it's a dead end. Then, if we look from engineer's perspective, he might see interesting components in his daily work, which could be suitable for additive manufacturing. But if he chooses additive manufacturing to be utilized as manufacturing technology, his manager will definitely require engineer to justify utilization of additive manufacturing. Of course, this manager knows that AM parts can be expensive, so he wants to understand what is the business case. And it's basically almost impossible task for basic mechanical engineer to create a business case out of nowhere for metal AM component. How he could know the cost of the component before creating a CAD model and before asking quotations? No way. Besides, it doesn't make sense for him. It's so much easier to design as parts has always been designed. So design for machining or casting, get your design approved and wait for a salary. No one will question your design solutions as long as you are using traditional manufacturing technologies, as stupid it is, even if there would be also cheaper options available. I see that all of these people have same problem. Even if they had an interest in additive manufacturing, the risk-reward ratio is just too bad from their perspective. Luckily, I see that there is a solution for that. We were able to identify one important question that is quite often preventing people from taking the leap and starting to utilize AM, and that is, what does 3D printing cost? If you think about examples on previous slide, there was always some kind of cost-related issue preventing people from starting to utilize AM. Purchasing was worried about the price target of the part. Manager has to be able to calculate if it makes sense to redesign a part for AM. In order to do so, he needs to know how much the AM component would cost in the end. Engineer might know that AM design has a huge impact on the final cost of the part, but he doesn't know how to make right decisions during the design process in order to minimize that cost. And finally, if someone somehow manages to create a part which would be suitable for additive manufacturing, they have no idea if received quotation is reasonable or not. These were pretty much the questions that I was facing 4 years ago when I visited our customers. I believe that all AM specialists working within their organizations and all people who would like to promote AM knows what I'm talking about. They have heard these exactly the same questions or they are asking these ones from themselves. We tried to find a way to solve this problem and started to look for available softwares or other solutions, but unfortunately, we were not able to find anything. There are softwares in the market which can be utilized to calculate printing costs, but those are typically online tools which requires existing CAD model. On top of that, those often require also uploading the file to cloud, and at least many of our customers are not willing to take any risks with IPR. So basically, cloud is not an option. Well, how about print preparation softwares? It would be possible to calculate print time, estimate machine costs, material costs, labor costs, and so on. But that would again require existing CAD model, which you don't have if you are trying to build a business case for AM design project. So no go. Rules of thumb, yeah, basic euros per kilogram rule of thumb is relatively good for AM plastics, but I wouldn't dare to apply that for metal additive manufacturing. AM metals is just way too complicated topic to be handled that way. So back to square one. There is no solution available in the market which could help people struggling with unknown 3D printing costs. We realized that actually Etteplan, as an engineering service company, has all needed competence in-house. We know how engineering is done, we have AM know-how, we have software development guys, and we can even create user manual. So we have been doing similar kind of projects for our customers for years. So why shouldn't we do one also for ourselves? So basically, we just decided to develop our own software for metal part cost estimation. Do it yourself. The result from the project was AMO tool, so additive manufacturing and optimization tool. We have been using the tool in our projects to create business cases for customers, and after 3 years validation and fine-tuning, We are confident that cost estimations provided by the tool are actually quite accurate nowadays. I believe that this AMO tool will help all organizations to smoothen the transformation and implementation of additive manufacturing in the future. And there are two major reasons why I think so and why this tool is completely different from the others available at the moment. First of all, you don't need existing CAD model. Rough idea about the possible end result is enough. This enables business case calculations and also removes potential IPR risks. And my favorite and maybe the most unique feature is that AMO tool provides guidance how current component could be modified in order to reduce production costs. At least I haven't seen anything like that before in the market. Okay, I have been now talking a lot about challenges and costs, but now let's move on to the real solution. Erin presented Wärtsilä tooling case last week, so at least some of you are already familiar with the project. Those who missed the webinar, go check it from YouTube later on, but for now, let's just utilize that as an example as I give a demonstration on how AMO tool works in practice. So on the right-hand side, you can see the target welding assembly, aka the drone or mug holder, which should be consolidated into a single 3D printed part. At the moment, we know the main dimensions 200 by 200 by 40 millimeters and current volume of the part. In addition to that, Wärtsilä had a requirement that production cost should be lower than 1,000 euros. I would say that this is extremely typical situation we are constantly facing every time when we are meeting our customers. Starting data and target price. I must admit that I couldn't say if 1,000 euros is a realistic price target or not for the component. So let's open our AMO tool. Here we go. So you remember that height of the part was 40 millimeters. Let's assume that we need to add approximately 2 millimeter support structure beneath the part. So total height of the part would be 42 millimeters. Then we know that current volume of the part is 280 cubic centimeters. It's not the final volume of the AM part, but let's use that as a working value right now. Part complexity, this is quite typical machine part. So this value is a spot on. Then machine type, what kind of 3D printer we want to use. The size was 200 by 200, so mid-range machine is suitable for us, and let's just pick one laser. Material, I made estimation that margin steel, so tool steel, could be interesting option. It's relatively cheap and has quite nice material properties. Then if we move on, we need to estimate how many parts could be fitted on the build plate. size of the build plate with one laser machine is 250 by 250. So our part would approximately reserve 50% of the total build area. So let's type 2 PCs here. We are not going to stack parts on top of each other. And as I mentioned, we will need approximately 2 millimeters of support structure on the bottom of the part, but otherwise, at least at the moment, part is self-supporting, so 5% support structure is enough. Okay, technical issues. Let's type numbers again in fast mode. So one laser, margin steel, two parts, one stacking layer, 5% support structure, 10 post-processing cost. So we need to estimate what would be the post-processing cost. I would say that only post-processing required is removal from build plate and aging of the material. So relatively simple heat treatment. Let's say 40 euros. And let's assume that annual volume for the part would be 50 pieces. Now we have all required information, and we have first estimation about the final cost of the part. And this is an estimation in as is condition, and you can see that we are well over target 1,000 euros. 75% of the total price comes from process cost. Then the second biggest factor is material cost, and setup cost and post-processing cost are not so significant in this case. This varies based on the part, but in this case, it goes that way. Then you remember that we have this target price of 1,000 euros. Let's type it over here, and we can move on to business case evaluation matrix. I want to see exact numbers in this case. So here we go. You can see that our current price estimation is located in the middle of the matrix. And then let's take a look at the build height. So current build height was 42 millimeters. And you can see that if we move on here upwards, so decrease the height, it doesn't basically change the production cost. And vice versa, if you increase the build height, it doesn't either change the production cost. So we know that while we are doing design, we can change the height and it doesn't have significant impact on the cost. But AM part volume, there is a clear change in the color if we move to the left. So first, color turns into gray and finally to the green. So gray means that we might have a business case. As you can see, if we have volume of 168 cubic centimeters, our price estimation is 1,012 euros. And if we can reduce the volume to 140 cubic centimeters, then we are well under our price target. So remember, 140 and 168 were the critical values. And I would say that experienced engineer can make a brief estimation if we can reduce the amount of material from 280 to target volume between 140 and 170. And this estimation can be made based on material properties. So We know that at the moment used material was S355 structural steel, and then in AMO tool we utilized tool steel, which has yield strength of 2000 MPAs. So according to our estimation, that should be feasible target. After this kind of calculations, it's way more easier for R&D manager to approve redesign project for additive manufacturing, and also easier for engineers to work with a clear design target. Designer knows that it doesn't make sense to decrease the height of the part, and he also knows roughly how much material should be removed in order to achieve the target. It was the same with Wärtsilä, and we were able to start the project after this estimation. We did intensive design and topology optimization, and finally we were actually able to reach the target volume. So final volume of AM design was 168 cubic centimeters. Let's jump back to AMO tool, see what does that mean. So here, let's change volume of the part to 168, and here we go. Now estimated production cost is 1,012 euros. We also helped Wärtsilä in purchasing process, and after receiving all quotation, actually the best quotation was 950 euros. So target was achieved. It was 5% lower than our original estimation, and I would say that typically estimations received from AMO tool are within plus minus 10%. I would say that typically that is a good enough estimation, but of course, if you are planning to produce thousands and thousands of parts per year, then it would make sense to finally make a proper print time simulation and detailed cost estimation before really starting to order those parts. But back to the tool, we will be releasing the tool during this year, hopefully sooner than later. Beta testing phase has been just started, and if you are interested, you can still apply for beta testing group before official release. Unfortunately, the number of beta testers is limited, but for now, there is still some room in the group. So if you're interested, send me email and let's see what we can do. I hope that you found the webinar and our AMO tool interesting. If you have any questions, I'm now happy to answer those. Otherwise, Tero, you can brief about coming webinar.
Thank you, Johannes. Like Johannes said, feel free to send the questions to the questions field, and in the coming week we will focus on industrialized additive manufacturing. Our Swedish colleague Henrik Delander will have a look at about what should be taken into account when thinking about serial production in additive manufacturing and what's happening in that area. And for the questions, we had one already had a written answer over there, but the question was that how well AMO tool estimates small parts with a smaller amount than 10 cubic centimeters. So I would say that it's pretty accurate. Maybe the part complexity is the factor that depending on the user who's using the tool, there might be a variations of the cost. But like Johannes said, since we are not utilizing the full CAD model, there is variation and or deviation in the prices, and we are in a plus minus 10% price range within this tool at the moment. And about the tool itself, like Johannes said, we will publish this tool for free for everybody to use somewhere during this year. So at the moment, the beta testing phase is ongoing, and if there is an interest to start to utilize this one and be the testers and give feedback for us about the working of how the tool works, feel free to contact Johannes Karilainen and apply for that test group. If no other questions, I will thank you for all of you for your attendance, and hopefully we will see you on coming week with Henrik Thalander's webinar, and we will stop this webinar now. Thank you everybody for joining.
Thank you.